In this video, we will take a look at what Euler's number is. To understand Euler's number, first of all we can take a look at this example. Suppose now I have a deposit of $1 and it has compound interest of 100% per annum. In this case, what amount can I get after 1 year? To answer this question, first of all I have to know the frequency of compounding. Suppose the interest is compounded 1 time per year. Then the amount that I can get in dollar after 1 year should be 1 plus 1 to the power 1, which is equal to 2. That means if I invest $1, then I can get $2 back after 1 year. On the other hand, if the interest is compounded 2 times per year, then the amount that I can get should be equal to 1 plus 1 over 2 to the power 2, which is equal to 2.25. If it is compounded 3 times per year, then I can get 2.37 something. And if it is compounded 4 times per year, then I can get back 2.44 something. As we can see, if the frequency of compounding is higher, then the amount will be higher as well. In general, if the interest is compounded n times per year, then the amount will be equal to 1 plus 1 over n to the power n. Now the question is, if n goes very large, how large can the amount be? Can the amount be very large as well? The answer is no. In fact, if n goes very large, the amount will reach a limit which it cannot exceed. This limit is known as Euler's number. It is an irrational number which is equal to 2.7182818 something, and it is denoted by E in mathematics. Therefore, we say that the limit of 1 plus 1 over n to the power n as n approaches infinity is equal to the number E. After knowing this mathematical fact, then we can further take a look at this example. In this example, the compound interest rate is equal to x times 100% per annum. That means if the interest is compounded n times per year, then the amount that I can get is equal to 1 plus x over n to the power n. Now we can ask a similar question. As n approaches infinity, what should be the limit of this expression? To answer this question, we can rewrite this limit in this way. And then we can do a substitution so that y is equal to n over x. And then we can say that as n approaches infinity, y should be approaching infinity as well, because x is a positive constant. After that, this limit in terms of n can be rewritten as a limit in terms of y, like this. From a theorem that we have learned, in order to evaluate this limit, we can put the limit sign inside the square bracket, like this. As we have learned that the part in red is equal to e, therefore the whole limit should be equal to e to the power x. As a result, we can have this conclusion, that is, the limit of 1 plus x over n to the power n as n approaches infinity should be equal to e to the power x. From this result, we can do some manipulations to obtain other interesting results. For this limit, we can do binomial expansion. After rewriting the terms in this way, and we assume that we can evaluate the limits term by term, then we can see that this limit is actually equal to an infinite series. It is equal to 1 plus x squared over 2 factorial plus x to the power 3 over 3 factorial plus x to the power 4 over 4 factorial, so on and so forth. In the summation notation, we can say that it is equal to the summation of x to the power n over n factorial, where n is from 0 to infinity. Please note that in this summation notation, we should assume that x is non-zero, because 0 to the power 0 is undefined. Also, please note that 0 factorial is equal to 1. As a result, we can have this conclusion. E to the power x is equal to the summation of x to the power n over n factorial, where n is from 0 to infinity. In particular, when x is equal to 1, then we should know that the number e is equal to the summation of 1 over n factorial, where n is from 0 to infinity. After knowing what Euler's number is, let's take a look at this. We have learned that if x is equal to a to the power y, then we can make y the subject of this formula by saying that y is equal to log x with base a. And of course, to make it a meaningful function, a should be greater than 0 and not equal to 1. This is the concept of logarithm, and a is known as the base of the logarithm. In particular, if the base is equal to 10, then we can simply say that y is equal to log x, and it is known as the common logarithm. It means that it is a logarithm with base 10. Now that we have learned the number e, if we know that x is equal to e to the power y, that means if the base is e, then we can simply say that y is equal to ln x, and it is known as the natural logarithm. It means that it is a logarithm with base e. It is called the natural logarithm because it is found that in nature, the number e is actually very common. For natural logarithms, they are logarithms. Therefore, they have all the properties of logarithms. To conclude, in this video, we have learned that the number e can be defined as the limit of 1 plus 1 over n to the power n as n approaches infinity. And the number e can be expressed as an infinite series which is equal to 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, so on and so forth, and it is approximately equal to 2.71828. Furthermore, we should know that e to the power x can be expressed as the limit of 1 plus x over n to the power n as n approaches infinity. Also, e to the power x can be expressed as an infinite series called the exponential series, and it is equal to 1 plus x over 1 factorial plus x to the power 2 over 2 factorial plus x to the power 3 over 3 factorial, so on and so forth. Finally, we should know that the natural logarithm of x simply means the logarithm of x with base e.